হ্যালো ভিউয়ার, বিএ ক্লাউড প্রোর প্রথম বুটক্যাম্পের পঞ্চম এবং শেষ সেশনে স্বাগতম। দিস ইজ দ্য লাস্ট সেশন ফর দিস বুটক্যাম্প। আমাদের এই বুটক্যাম্প মূলত হাইলি স্কেলেবল অ্যাপ্লিকেশন ডেভেলপমেন্টের উপর এবং এর বিষয়বস্তু বিল্ডিং স্কেলেবল মাইক্রোসার্ভিসেস ইউজিং মাইক্রো ফ্রন্টেন্ডস অ্যান্ড কুবারনেটিস। Today is our session 5, that is Docker node deployment and Kubernetes with Traefik. Our bootcamp tutor is Manna Mahmud. তার পেশাগত পরিচয়, তিনি হেড অফ ওপেন সোর্স প্র্যাকটিস অ্যাট কারিগর, ঢাকা। ভিউয়ারদের বলতে চাই, আজকে বুটক্যাম্পের পঞ্চম এবং শেষ সেশন। পরবর্তী সেশনগুলো দেখতে চাইলে আমাদের ওয়েবসাইট অথবা ইউটিউব চ্যানেলে ভিজিট করুন। শুরুতে আমরা দুটো রিকোয়েস্ট পাইছি। There's two requests from viewers. There's a non-Bengali speaker, so he's requesting that if you can present it in kind of 60% English, 40% Bengali, and Manna bhai, if you can share the slides of all of your presentations, that it will be helpful for them, all the architectural diagram and other things. Today with me, the co-host is Ashfaq Hussain Ahmed, who himself is a full stack developer. আজকে আমাদের সেশনে আলোচনা করব রিক্যাপ অফ প্রিভিয়াস সেশনস, ক্লাউড নেটিভ ভার্সেস ক্লাউড অ্যাগনস্টিক আর্কিটেকচার, OpenShift Kubernetes in local machine, Traefik-ingress-controller for Kubernetes, config maps and secrets of Kubernetes, console discovery in Kubernetes, deploying API gateway in Kubernetes, deploying Kafka in Kubernetes, deploying microservices in Kubernetes. So many Kubernetes, so it's all based on Kubernetes today. Just deploying all our projects previously have done, we'll do it in Kubernetes today, and finally there will be QA session. অনুষ্ঠানের শুরুতে আমি লিসেনারদের বলবো বুটক্যাম্প সম্পর্কে তাদের গুরুত্বপূর্ণ মতামত bacloud@gmail.com এ ইমেল করে জানাতে পারেন। টেকনোলজি রিলেটেড গুরুত্বপূর্ণ ভিডিও আমাদের ইউটিউব চ্যানেলে আমরা নিয়মিত আপলোড করি। এছাড়া পরবর্তী ওয়েবিনারের ভিডিওগুলো দেখতে চাইলে আমাদের ইউটিউব চ্যানেলে সাবস্ক্রাইব করুন এবং আপনি আপনাদের মতামত আমাদের সোশ্যাল মিডিয়াতে জানাতে পারেন, আমাদেরকে ইমেল করে জানাতে পারেন বা ইউটিউব কমেন্টসেও জানাতে পারেন। আমি আমাদের এই সোশ্যাল মিডিয়ার সমস্ত ইনফো আমার মেসেজে আমি দিয়ে দিচ্ছি, আপনার সহজে যাতে ক্লিক করে ফলো করতে পারেন আমাদেরকে বা ইউটিউব চ্যানেল সাবস্ক্রাইব করতে পারেন। তো দেরি না করে ঝটপট করে ফেলুন। ভিউয়ারদের অনুরোধ করব তাদের প্রেজেন্টেশনের সময় কোনো প্রশ্ন থাকলে চ্যাট বক্সে জানাতে। শুরুতে আমার কো-হোস্ট আশফাক হোসেন আমাদের কাছে বুটক্যাম্পের গুরুত্ব সম্পর্কে তার মতামত শেয়ার করার জন্য বলবো।
Hi everyone. Hello Manna bhai, কেমন আছেন? So ultimately we are at the end of the bootcamp. It has been a pleasure, Manna bhai. We have learned a lot. Thanks to you for your time and all the knowledge you have shared with us. And আমরা আসলে যেটুকু আমরা করে এসেছি আমাদের পুরো বুটক্যাম্পটাতে, আমরা কিন্তু একটা প্ল্যাটফর্ম ইন্ডিপেন্ডেন্ট বা অন্য কোনো কিছুতে ডিপেন্ডেন্সি না রেখে আমরা কিন্তু আপনার পুরো জিনিসটা যদি আমাদের প্রত্যেকটা সেশন আমরা ফলো করি, তাহলে আই থিঙ্ক আমরা যারা অন্য টেকনোলজির আছি তারাও ইজিলি আপনার স্কেলেবল অ্যাপ্লিকেশনস কিন্তু করতে পারে। সো উইচ ওয়াজ অ্যাকচুয়ালি আওয়ার গোল, রাইট? সো ইনশাল্লাহ ফিউচারে আরো আপনার কাছ থেকে অনেক সেশন পাবো, আপনাকে জ্বালাবো ইনশাল্লাহ। সো আর আপনার এট দি এন্ড অফ দ্য ডে আমার রিকোয়েস্ট থাকবে ভাই, আপনার সোশ্যাল মিডিয়া লিঙ্কস গুলো যদি আমাদের একটু দিতেন, এট লিস্ট টুইটার এন্ড লিঙ্কডইন দিলেই এনাফ, so that we can follow you and follow your activities. Thank you so much, brother.
Yeah, Manna bhai, I just request you to, if it's possible, to make it 60% English, 40%. So there's a known Bengali speaker, and I want all of them kind of be comfortable with this session. So, okay. Manna bhai, please continue. Please start your
Thank
session.
you, guys. Thank you, Ashfaq and Samar bhai. So we are going to start on that. Previously, we have already done most of the sessions, all the 4 sessions previously. So today we are going to do the last session. So this is on all multi micro frontends and microservices. So this is basically distributed scalable platform we are going to show in a cloud agnostic way. So, and me, Manna Mahmud, I'm doing programming in Java for last 15 years, and for almost 13 years working with software designing with Java. So let's come to our index. We have done so far so many things, so we will do a recap today. So we had a grasp over all the things. Kiki kursi amra, we should review a bit. Then this philosophy behind all these bootcamp doing things to not get dependent or vendor locked. We have tried to follow a cloud agnostic architecture, a strategy. That why we have done, and what's the difference between these two things, cloud native and cloud agnostic. We'll try to show that. And I have installed OpenShift CRC platform, Kubernetes local machine. So I will show all these things how to deploy in Kubernetes. We have previously done a similar cluster environment, Docker Swarm. Now we'll do this whole thing for Kubernetes. So in Kubernetes, then we have to integrate our reverse proxy traffic, and we will use it as a ingress-controller. Then we will use config maps of Kubernetes to keep secrets and certificates. Then we will deploy the console discovery. Then we will deploy our API gateway, our frontends, micro frontends, and we will deploy Kafka in Kubernetes, and then our microservices. So this is just deploying. So we will not do any development of services or other things. It will be the last Docker build we have done in Docker Swarm. It's the same Dockers going to be deployed on the Kubernetes. We don't need any change to do. So before we go to this cloud native and cloud agnostic, we should see, and we have another request. We have one slide previously, so we just recap what we have done so far and why we have started that. So we know that this microservice concept have started previously because we were, industry is suffering from these monolithic developments, scaling these monolithic systems is very hard. So we have started developing architectures with microservice way, and we have discussed these things. What is microservice? It's not just breaking or making REST API. It has to have each microservice must contain these features, like it should have a proper domain design. It should be driven by a team, developed by a team. It should have independent deployment, independent release planning, independent storage, RDBMS or any other DB, and then it will become a microservice. But the problem industry is facing, we are trying to go a bit bottom up. We are building so many microservices, but trying to show all them in the one UI, one front end. So that approach is making a trouble. Again, we are having a front end that is basically a monster, again a monolith, and even with this React, Angular, or this PWA or single page application, we are having issues getting it very critical. Though we are having microservices, but we are making it again a monolithic situation by having a single front end. So recently, people have come with idea of micro front end. So it can be very useful if we create single pages and small single pages. Already we see Google is implementing small micro contents like Gmail, contacts, Keep. So, but when you want to do similar sort of things, the most important thing is that you have to have good design. seamlessly, so user may not feel discomfortable, I mean, with the UIs having different front ends. So it should have all have similar things, and the login should be one. There should be SSO, single sign. So user login in one front end or from one URL, and he's getting all the front ends easily by one login. So we have to have an authorization server with single sign-on, and we have to have a proper proxy, reverse proxy, that will map all the UIs and services under one domain. So to user, it will seem like one platform, one solution as a service. But we will in the backend will have multiple front ends and multiple backends. Why this is? Because when we have that, we will have independent teams that can handle each services and the front ends easily. So what I try to cover in the last things, that this gluing, making all these front ends and back ends connected, this is basically what we call microservice ecosystem. We have to develop a microservice ecosystem that everyone can communicate with each other and transfer data to the user seamlessly. আমার ডেলিভারিতে কারো যদি কোনো প্রবলেম হয়, বুঝতে সমস্যা হয়, বলবেন, হ্যাঁ, will flag, raise flag, so we can slow down or we can make it faster, so things not get hard for you. So this is the thing we are trying to say, the ecosystem. So we will need a proxy server. So we are going to use, or we have used in this all these sessions, Traefik, HashiCorp Traefik, developed in Go language. And then we will need SSO server. We have used Keycloak. In every cloud, you will get an IDP. There is Okta and so many other SSO servers, authorization servers. But we are using here Keycloak and this Traefik.
Manna bhai, can you share the slides also? You can't see anything.
Oh, we have not shared the screen, right?
Yeah.
Okay, I thought I have shared it already. So that's the reason I was not understanding. So
yeah, that's fine. You can just repeat a little bit so that
I was basically showing the slides, but the screen was not shared.
Yeah, that's fine. You can just recap so that everyone just make a connection.
What we were showing the slides, that if you break these things, only making REST API is not microservices basically, and this monolith situation we are creating with the front ends now. We are making microservices, but we are having a monolith situation with the front end. So we can have small front ends that combine together with SSO and the reverse proxy. So this reverse proxy and this SSO is most important to make an ecosystem. And then in between this front end and microservices, we will have API gateway. We have developed it with the Joule 2 API gateway, and then we will need a console discovery service. So we are not picking anything that is tagged with any vendor. It's not like AWS service discovery, AWS API gateway, or GCP or Azure. We are selecting all open source things, not dependent on any vendor. So that this approach, this strategy, choosing the tools that you can use your own, this is called basically a strategy cloud agnostic way. So there is no vendor lock-in. Now we can deploy this in any Kubernetes provider or container in any cloud. It could be Azure, it can be AWS, it can be anything. So that's the thing. And to make understand properly, we have tried to show this one. This is the basic thing. If you want to understand the why, how this will be managed. So if we are trying to build a B2B commerce or something like that, a platform where there is different kinds of customer, different kinds of requirements. User end is different, like delivery man, customer, employees. So you want to develop an app, maybe a delivery PW, which is React or Angular, and it should consume some microservices. So it has a different domain, different requirements, different customer ends. There can be different delivery teams. So we can think it as a microservice micro frontend that is different from the water management frontend, which can be different from the customer support management frontend, which can be totally different for employee task management. So making all this into one single frontend will create another trouble. So this is why we are preferring, or we are showing this way. We can develop this depending on the customer requirements or user end segmentations, that we can have different micro frontends, but we can serve it with single domain by having this sort of path mapping or subdomain mapping by the reverse proxy. And then we can serve it with a single login by this SSO server or authorization server. Then we can distribute this API gateway. You can make it one, or it can be independent, wrapped with this front end. So each front end can have its own API gateway to communicate with the microservices. Following this console registry of the microservices. So this is the thing we are going to do now to deliver to develop a delivery man app with the microservices, the release planning, the deployment, CI/CD. It doesn't need to be dependent on the this order management app. So there can be a release maybe going on 1.1 for delivery app, or it can be 1.0 for the water management. So there can be different teams independently working with independent release plan and CI/CD. That's the benefit of having microservices. If we cannot achieve this, microservices can be more painful. Already it's a distributed system, more critical. So having this sort of independent deployment of different problem domains, it will give the ease of development, and then delivery will be more faster. That is the vision or mission we are trying to go through. And this is the only one slide basically we have used so far. And in each session, we just have reviewed that. So I will share that slide with everyone, no problem, end of this session. So now we can go to, we already say that, if I make it bigger a bit. Okay. What is cloud agnostic platform? So I have already said practically that cloud agnostic doesn't mean anything. I mean, you have to do any different architecture or something. It's like choosing not cloud dependent things, the platforms that we need, the API gateway, the proxy, the discovery registry, the authorization server, the DB services. So if we don't pick those things from the cloud platforms, like I'm not going to be AWS native, I'm not going to be GCP native, then it will become cloud agnostic. What is the benefit? Now this solution can be deployed in any cloud environment, and also it can be multi-cloud. We can distribute it within several cloud vendors and act as one. So that's the benefit of having cloud agnostic platform. And cloud native is simple. I mean, as we say, Android native, iOS native, AWS native. So when we are using the services that is solely built on AWS, like AWS IDP we have seen yesterday, Cognito. This is their SSO and IDP service. If we use that native thing from cloud AWS and build everything with AWS ecosystem, then we are locked with AWS and we are becoming AWS native. If we do the same with GCP, we will become GCP native. Then it happens like we can't migrate easily from one vendor to another vendor if the situations come, or becoming multi-cloud will become problem. So that's the thing of cloud native. And as I said, so it's not like, again, mutually exclusive. We are developing something cloud agnostic, we are free. So sometimes it can be like, okay, I am liking a service from the cloud or the vendor, I'm going to deploy. It can be also like I can replace maybe a key clock with AWS Cognito. I can replace maybe the DB service from that cloud provider, not our own DB or Postgres or something like that. So the benefits we are getting, we have already discussed. We can avoid the vendor locking. we can have our customizations as we do. We can have risk reduction. We can choose precisely what we want, and we can choose the best, and we can have our own optimizations. It will reduce cost also. And the security, if you choose the best options, best secure teams, so it will be more secure. You are not bound or restricted to go with whatever the vendor is providing. But in case of when you are going to be cloud agnostic, it is a bit strategical. You have to do many things with your own, a bit like do it yourself. So that in that case, the bootstrap wizards that AWS, GCP, and so many cloud platforms are giving to wrap up and start the thing very fast, that will be hard. I mean, that is not going to be available. So maybe in AWS, you can start a Kubernetes cluster in a few minutes by clicking some things and start working. That in cloud agnostic, you have to plan, you have to go deploy yourself things. That's the thing going with cloud agnostic strategies. But in case of creating distributed large systems, I like the bootstrapping or the foundation of a platform should take time. You should think, you should give more time. Using wizards are not always a good way to start a big platform development. I mean, very quickly. So you should give time when you are starting a thing. And when you are doing the microservice, I mean, of course, microservice or distributed application, it's not for small things. If you are developing a small app or something, I think the microservice is not a good option. But if you have a very large something you are going to develop in a distributed way, the microservice is the best option to go for. And it's proven now and people are liking it. But when this is big, starting quickly with the wizards, I will highly not say the good wise way to do that. But most of the time people are going to the cloud vendors and becoming their fan because they are giving a very quick startup. You can easily start a project and start things nicely. That facility basically not giving you the foundation properly, or maybe you're skipping so many things or not thinking properly. In the further way, when you are becoming big, then you are finding that, okay, my foundation is not that good. All the wizard values are basically default, and going default values when things are going big, you will have issues. So that's the thing. So now we can go our own way. So we can do it in any cloud platform, in GCP or AWS or anywhere, wherever they will give us a Kubernetes cluster, we can do it. But to show it locally in machine, I just installed OpenShift. So I will show you. There is easy thing. I think it's very, it's quite easy. If you go there is a CRC platform. It is called Code Ready Container. You just have to download it from the Red Hat and just install. That's it. If you install it, it will just give you something like a CRC, this file, and you just have to start it. If you start it, it will just this command. If you give a start, then it's just started the whole cluster platform, and it will give a good UI for you to see all those things that normally in GCP and AWS, if you have a cluster manager, if you want to do deployment, you will get something similar where you can map the storage, the networking, the services, the deployments, workloads, all you can see. So you will get a similar platform if you install the OpenShift. So this is a mini version of OpenShift that is specifically built for install in your local, laptop or in machines easily. For if you have only 4 GB RAM or something like that, you can do that. Even I have created a video for that, how to install it if you feel trouble. So I have a 10 minutes video. You can see it here. I have just,
hi everyone.
Yeah, sorry. So you can, I'll give the link.
Can you just share the link in our chat box, a message?
Just finding. Where is the checkbox? Perfect. So yeah. So there is a
and also the previous link.
Okay.
The OpenShift one.
I will share the slides also.
Yeah, that's fine. If anyone is interested to take a look on that.
So here you can go and locally install the thing, so you'll get a good Kubernetes. OpenShift is nothing but a
Thanks,
wrapper
Manna
over Kubernetes, so it's giving all the Kubernetes things along with some extra features you can use if you want. But we just need to deploy it in Kubernetes. We are not going to show Kubernetes tuning or Kubernetes deployment or administration. We are going to show how to deploy our architecture in this environment. That's it. Nothing more we will trying to show in the Kubernetes. So let's see. So if we go to our slide. So we have that now. So we can install it. I don't want to show it here. So this is the thing we have done. So now discussing a bit, reviewing the previously the strategy we have taken in building micro frontends with Angular or React with Spring Boot. It can be with Laravel, it can be with Python, other frameworks like Django or something. So what we have to do, we have to have a firm integration. We have to provide the front end with some features like developing the front ends with some framework to give it some flexibility to have a good integration with the SSO server, the Keycloak or the Cognito or the Okta, whatever. It should have a SSO integration. It should have integration with the console discovery or any other discovery you will use. It should have a good integration with the API gateway, and then it can be easily Dockerizable, and it should have a easy build mechanism. We have developed those things. We have seen those things in previous sessions, and it should have a monitoring integration with the Prometheus and Grafana, other things, any tool you want. And then the thing is to communicate with microservices. We have to have the API gateway, the capacity to relay the tokens from the front ends to the backends, I mean to the microservices. So that's the thing we have done previously in our codes. I hope I don't have to repeat those things. If you want, maybe I can show it later on, but I think it's fine. So far we'll go to code and we'll see those things again. And then we have done other things like deployed Kafka to, if we want to do something like event-driven or message-driven development, PubSub architecture. If you want to do this, so we'll need some message broker. We can use Kafka, we can use ActiveMQ or RabbitMQ, but yes, it is, we have done with Spring Cloud Stream, and all these things basically in our ecosystem, this proxy, authorization server, the Kafka monitoring tools, and a console registry or service discovery. And these are all connected with these our microservices. We have developed some microservices. Those are connected with these API gateways through this console service discovery, and each microservice can communicate with each other. We have shown that already with the HTTP client, any tool that can relay token one to another. Then we can easily call one microservice to another and create a proxy pattern, so that microservice 1 can represent some methods or some data from microservice 2. So front end doesn't have to worry or call to show a one single list or one data, specific domain data from calling different services. So we can have a single call to get one single data structure JSON from one service, and that will manage calling other services and prepare the data, map the data. So that we have seen already or shown already. So let's go to the what is our, again reviewing those things who have not seen that. So this is, we have created a mono repository, as people are saying. So preferably, if you are doing a big development, it should be better for delivery app, for this whole thing, for front end, for microservices, and for other things, it can be one repository. For customers, can be one repository. I mean, depending on the CI/CD and other things, you can have different code bases. Even you can have for each microservice different code base, and for each front-end different code base. So breaking too much is also trouble. It makes trouble to integrate or find things. So I will prefer to maybe this sort of team-wise making code bases, or keeping similar required domain-based microservices and microfunctions together. But here we have done one and put all these things all together. You can have a miniature version as you want. Whatever will happen, your front ends will stay in this front end folder, and your backends or microservices will in this microservices folder. And the infrastructure things and deployment things, you can call this folder also deploy maybe, or infra. I am calling it edge. So here you can keep all the deployment files depending on the environments, test environment, pod environment, local environment, Docker Swarm, Kubernetes. Depending on that, you can make variations of profile management. So that's the thing of the structure we have done, and this is the thing. We are trying to build the whole thing in the POM. I mean, in Maven, through Maven. For other platforms, there are several build tools you can use, but Maven also goes with Python. Also, you can do with other, and even .NET things you can build with Maven. I have done these things with all other platforms. Maven goes easily. You have to tweak a bit. There are plugins you can use for .NET, Python, and other things. Easily plugins you can build. So Maven gives a good building mechanism and composing the whole thing easily, making a package gives a good feel. You can see a good structure. So previously, what we have done in Frontends, if I show that services, so that was really, we have generated the Angular app in this web app folder. We can even use React similar way. And to build that, we have used this plugin. One plugin that is a very common plugin to build. Let me show. Yes, for Node.js build Node.js applications. So this is a Maven plugins. So you can use it. So it will go to the web app, and it will just build the Angular app, and it will map it to this public folder, and then we can serve it through our Spring Boot application, which is also will act as an API, and also it will be connected with a discovery client. Here we are using console. And this configuration, so we have seen previously, we can have profiling over here, different profiles. In Maven, we have also used profile. So we can have dev profile and prod profile to have different plugins if it differs, or the properties if you want to change. And based on that, we can have different ports and profiles or other things according to prod and dev environment. So just have a sample over here. And here we have integrated the SSO client. Here we are using key clock. We just need a client, a provider of OIDC, OpenID Connect, and that is basically our key clock integration. We do not need much, because we have used the dependent library here. Yes, yes, the OAuth2 client. So that will give all the required clients binding and codes required for that. And we need just to give this. And Okta, if you do with Okta or other SSO server, it will be similar. There will be no much difference. You have to need those. You have to install or get these URLs and just configure this way. All are similar. And then we have connected with console discovery, so given him some paths to check the health. And then we have integrated Joule, and registered only one service. You can register so many services, and we can fine tune the timeouts and other things, but we have kept just simple. And we have exposed some metrics to have monitoring with Prometheus. And for each of this configuration, we needed the dependent library for each of your frameworks. If you are developing in Python or Laravel or whatever framework, you will need similar things. You will need the dependent library. Maybe in Python it is called requirements. Laravel it called dependent libraries. Maybe so you have to have these libraries installed. Like we have installed it here with Maven, the plugins. This is for Dockerizing. This is for compiling. This is for making war. So this sort of libraries this is for SSO. So you have to have these libraries, then you have to have a configuration. So the library, dependent library, and the configuration. Here, this is not different. The same thing you have to do for that. And we have integrated Kafka also similar way. And that is similar configuration. Well, yeah. So here, like Kafka with Cloud Stream, we just here we have just shown the Kafka port and URL, I mean host identity. So it is integrated, and the topics where it will be mapped. You can find it in the, I mean, maybe in the 4th session. If you want to be interested, you just go and see the video. So this way we have integrated. Again, similarly, if you want to integrate Kafka, we will need the dependent library of Kafka. That is also maybe in this service we have integrated, and we yes. So we have added these dependencies for Kafka. Rest are similar as the front end we have done. In front end, we had this dependency to build the Angular, but in microservice development, we don't need this Angular part. It's just other things and the metrics and some extra libraries that we have added. So that we have so far done. And then previously what we have seen that if you want to develop locally, so you don't need to maybe you don't want to use Docker Swarm or Kubernetes. You just want to start the server, single front end, or maybe a service and debug it or work something like that. So maybe that you want to have a Docker or something like that. That is not connected with the cluster environment. So this is something we have kept like that, which is simple Docker Compose without Docker Swarm and other things. You can start those things. Even without Docker, you can individually run each app. We have shown that, and you can debug it. So keeping all these flexibilities for the local development environment. So locally you can have the Dockers and test these things. Now locally, even if you want to test the whole thing in the Docker Swarm cluster environment, we have seen that also in maybe in session 2 or session 3, we have seen that how to deploy the whole thing and with Kafka and other things, everything in the Docker Swarm environment. And we have a visualizer also, Swarm Pit, and we have used all these things for in Swarm. Now the similar thing without changing anything, we just want to deploy it in Kubernetes. That's the facility of having this cloud agnostic way. So we don't have to do changes to switch vendors or switch cluster managers. Like now we are going to deploy in the OpenShift. It is providing a Kubernetes distribution. There is K3s, another Kubernetes distribution. GCP is providing another Kubernetes distribution. Azure is different. Oracle is different. Everyone is different distribution is providing, but they are having similar same standard. So when we are doing this, cloud agnostic way, our deployment will work. Maybe need some twist or tweak, maybe for routing or exposing services, something like that. But it should work with all the Kubernetes distributions. Similarly, it not only Kubernetes, it's also work with the Docker Swarm. If there is any other standards, we can have the deployments like that. Now, when we are going to deploy the whole thing in the Kubernetes, we know The Kubernetes is routing mapping. They call it ingress. So all the routes and other things, they call it ingress. Ingress is also means route basically. So now we are going to use this ingress controller of our own. So we are not going to dependent on the vendor or the distribution of the key clocks ingress controller, whatever they are defaultly provide. So we are using the Traefik. We have done everything in Traefik. So we have to integrate Traefik with Kubernetes. So this is called custom resource definition. So we have to define some resources. So some resources like ingress route. Then we have to, I mean, this is a replacement or alternative of the Kubernetes ingress. So it will work for mapping the paths and the domains. And this and we can get these things. It's not something I have to write down. If we go to Traefik site, Traefik, I think Traefik doc, right? Doc.traefik. Yes, something like that. So here it has very good documentation. You can go. There's a guide. So they have given all the custom resources, cluster resources. They have in this root definition. So then the service account definitions. So I just have copied those things. Nothing. Some rules, RBAC rules that is given in this ingress controller. So the permissions. So I just copied it, and I just made this file. This is where called custom resource definitions. So if we go to our deployment. So here there is a way to view that custom resource definition. So if we write here Traefik, so we have spelling mistake. So we have deployed 1, 2, 3, 4, 5, 6, 7, 8 custom definitions, but we are going to use basically only one ingress root currently, and this will give us this ingress root TCP UDP middleware, but we will just use this ingress root to show differently, and you can see multiple uses depending on how you want to do, because this ingress root will give you all the features of if you want to load balance, sticky session, all these things you want to do this, you have to do this with this ingress controller. So here also there is a guide if you want to do this like ingress route. It will give you detailed how you want to do the load balancing and how to define those things. There is only declarative, you don't have to do much things. So we have done similar. So we have defined one file with this custom resource definitions, and second file is basically deploying the ingress engine itself, I mean the Traefik engine itself. So exposing this 3 ports, the SSL port and the web port and their admin UI port, the UI we want to see. And we have deployed these things, and we have declared this ingress route. So we can find this ingress UI with this namespace, with this UI, we can find it here. So like that. Yes. So this is previously we are using only this mmb.mmfb.com. Currently we have made this domain pointing to this cluster. How we have done that? So this is something. Yes. So this is the IP of my CRC cluster, the node. So I have pointed all the domains to this. So now this is coming to that, and the ingress root is finding it. So, but to do that, I had to expose in any cluster environment. You have to expose the cloud you are depending on, that port forward or expose the service. And here in so we have defined a route. So you can see this traffic. So this route we have defined. Let's see this in the like this. So this is OpenShift specific a bit, like we have to declare expose this service, traffic service to this URL to make it public. So that's the thing we have done. Rest we did not need to do anything. And then if it comes to this network, then this is going to be handled by this traffic proxy ingress controller, who will, if he finds this URL, he will forward this to this port, and this port serves this URL. Yeah. And then we can see that he is finding all these Kubernetes containers as we have defined. Now we can see we have defined this auth server. This is the key clock we have deployed already. This is on this URL. Now how we have done that? As we have done in Docker Swarm, nothing different. So we just define these things. Oh, and how this is how we have done previously. I have discussed maybe. This is called Compose. There is a nice tool, Compose. So it helps you to convert the Docker Compose file. So we had already this Docker Compose files, right? In Swarm, all these Docker Compose files. So you have to write this single command like compose. I show you that. So it will give you this compose and then convert. And if you see you can send a parameter of Docker Compose file, it will convert this to a kubectl, I mean a deployable file for Kubernetes. So that's very easy basically with the tools. So I have done this way. So I have converted this key clock deployment over here. We have it like this key clock deployment, this service, these environment variables. For Docker Swarm, we had this. So similarly, it has converted here. Here, yes. So just we need three parts now. One is deployment, one is service. So we can find a service here. There is a auth service already running. Okay. And then there is a deployment where we are passing, and we have mentioned the service account. We have created the service account here in deployment. This is the service account for Kubernetes, and this service account we are referring everywhere. And this key clock deployment, here all the parameters, environment parameters just came from. Similarly, we don't need to change anything except this path. This path was different here, right? It was only www.mmfb.com, but in Kubernetes we are just increasing a subdomain, making domain a bit longer. So we have made it mmfbcarrier.com. So www. So this one. So we have changed this path only. Rest of similar same, and we are using H2 in memory DB for now, because if you want to run the clustered key clock in Kubernetes, you need, if you want to use Postgres, you have to have a clustered Postgres with pgpol or something. You have to deploy Postgres cluster. So we don't want to go on that part. So we just went easily, and we just included referred DB vendor H2 here. So in memory, it will be easy to show now. Previously, we have used Postgres in Docker Swarm. The single instance was enough, but in Kubernetes, single Postgres will not work with key clock. We have to deploy a proper clustered Postgres if you want to use with key clock, but in memory will go easily. So we have used this in memory, and then we have defined this route. Now, if you want to, if you make it more cluster and other things, and you want to use some specific load balancing ways, you have to find these ways from this Traefik. They are using some straightforward load balancing. There is weighted round robin load balancing. There is a mirroring. There is some stickiness way to defining cookies. So it can get sticked with this specific node. So this is, you have to deploy yourself. I don't want to go specifically on those things. These are some specific things that we are not showing this in detail about how to administer these clusters and other things. We are trying to show that this architecture, it comes here easily and you can easily customize it as you want. Now, here is a trick or important thing, that if you want to use this HTTPS certificates, so previously we have used these certificates, these traffic, config, and these cert files, right? We have generated these cert files with make certs. I have shown it earlier. You can generate it easily. So in Docker Swarm, it was easy. You just have to have a mapping, and that mapping was easy, like this one, like this. You can easily map, and the volume will be available, mounted, and it will work, and you can show the paths here in configuration like this. But it's Kubernetes, if I want to use these volumes or files available, how we are going to do this? So for simple configuration, certificates and keys, secrets, we can use Kubernetes, a nice feature that is we are calling config maps and secrets. So how this works, let me show you. So now I have to start this traffic. If you have any questions, please be friendly to ask. So what we are doing here, we need to map the certificate. So we are mapping a directory here, traffic. That
Viewers, if you have any question or need clarification, just put the question in the chat box. I'll forward it to Manna Mahmud. আপনাদের কোনো কোশ্চেন থাকলে অবশ্যই সেটা রেজ করেন, আন্ডারস্ট্যান্ডিং এ কোনো প্রবলেম থাকলে অবশ্যই বলেন, আমি মান্না মাহমুদের কাছে ফরওয়ার্ড করে দেব প্রশ্নগুলো। Please continue, Manna.
Okay. Okay, fine. So let's do it. I think yours is fine. Switching from two languages is a bit tough. So if you start with English, maybe it's always happening in English. If I start with Bangla, maybe it will happen in Bangla. So I'm staying with my own pace. So I think it will be fine with you guys. So it will be not a trouble. Okay. And now the traffic is, I'm trying to show you this, how this traffic folder in Docker we can map now. So there is a volume mounts and then there is a volume config. So we have to map 3 files. If you see this certificate, this is a cert file, this is a key file, and this is a trust store. And what is a trust store? If you remember, if you have not forgot, in every Docker we had to make a declaration in entry point, like we had to show for in Java JVM to trust our certificates. So why this? Because this is a self-signed certificate, not any popular vendor or recognized vendor provided CA. So it is a custom, so JVM will not recognize. So when these Docker services like the Frontends and the microservice will try to authenticate with the key clock in HTTPS call, that we are making this HTTPS calls in between this auth server and this resource servers, then it will give a handshake trouble, because they will not recognize and they will create trouble that the CA authority is not known. So we have to make this JVMs trust these certificates. So that we have already seen in Docker Swarm and other places, but in Kubernetes we have to map these things. So these 3 files we need for every route or ingress route to map. So how we have done that, that's a trick I have done. I just want to show this. So I have created this config data in config map. So how we have done that, maybe I have kept in the readme file. I'll show you that. So this config map, this is the command keywctl create config map, config data from file traffic. The 3 files, I have shown these 3 files. Okay. And okay, another created, I have created this task store, this task store. So one config data I have created with these 3 files. No, sorry, not this one. Where is the Kubernetes? Yes. This traffic YML is referring the traffic configuration, traffic to recognize the certificates or load the certificates, and another 3 is basically referring for trust certificates and other things, and I will show this how. So now if you go to the DeepMind, so if you write this one, okay, before that maybe I have to log in console. So you have to, I have to log in this cluster in OC is the OpenShift console command basically, and I want to log in as okay. So that there is a, we have to source the environment basically, find this OC in environment. So we have logged in namespace basically. In OpenShift, they are providing a namespace feature for, in Kubernetes, this is, there is a namespace feature. So it's, if you create a project in, like there is a project, so many projects. So I have created a project called dev name, MMFB dev one. So if you create a project, it will create a namespace, Kubernetes namespace. So you can create all your Dockers and all your configurations and other things in that namespace. So we are going to have this namespace. So now if I run this command, so from this namespace, it will show you. Okay. So this is the key. This is the val. File name is the key, and the value is the value, content. File name is the key, and the content is the value. This is the way config map keeps the data. And the interesting thing is, when you, what is that? Yes. When you map the volume and say it is a config map, then it will create automatically in this mount point those 3 files with the names of that file, so that the traffic can find this under this traffic. You have seen the MMB fcert PM, MMB FB key file. So these files will be copied or mounted on this folder in with this name, as the file name is that. According to file name, it will create the files. So it's pretty simple in this way. And if you go to this config maps, you can see here also, you can visualize that. And another, the task store, we have created the task store, and it is a binary data. So it's also kept like this, file name and the data. So it will be also mounted on our front end and services that we will show. And we have created a secret. Why the secret is needed? You can create a secret this way. What is that? Okay. Create secret, TLS secret, and you can give any name. And then you have to show with the cert parameter, certificate file, and the key parameter, and the files. And it will create the certificate file, and that we can use in our this ingress route. This ingress route, we can use this as a secret, then it will use this certificate for this host or this path HTTPS. So that's the way we have managed it. Okay, so we have kept these things in the config map and secret file, and then we used it in our deployment configurations or their names. So this certificate management is done. For certificate managing, we need to do 2 things basically: map the volume and mount the volume in the appropriate place and show that path to traffic. And in ingress root, declare this TLS secret. So you don't have to declare the file directly, you just have to declare the secret and it will be okay with this ingress route to provide the HTTPS. That's it so far. And this way you can see all these things we have done already available, exposed in this file. So we have seen, so we can log in. Yes. So this is the key clock server we have initialized, and we have created a realm, and we have created a client that will give access, and we have a user also created a user here. That user can access the things. So now we have our these two things, right? The ecosystem, we are saying this traffic, this traffic is already in Kubernetes as it was available in Docker Swarm, as it was available in our standalone Docker Compose mode, and also this SSO. When we have these two wrappers of the ecosystems binding the main core elements of this microservice ecosystem available to map all the paths or the routes and giving the authentication and authorization layer, which can be the benefit of having key clock. It can be a broker. It can be connected with Google Auth, Facebook Auth, LinkedIn Auth. It can work as Auth to broker. It is a Auth to server. And then it can have integration with LDAP or AD servers. So that's the biggest facility. You are having this whole wrapping of having access management and route management. I mean, and the certificate management. So all the IO that is coming to your platform or ecosystem, all the IO in a specific domain now can be authenticated as you want, with as authorization you want, and you can distribute it on the paths or according to path, whatever server you want. And then the front ends, you want to load balance. If you want to load balance the front ends, you can load balance the front ends with the traffic. Traffic will not be used to load balance the microservices. Traffic will be used to load balance the micro front ends. The micro front ends, if you want to have multiple instances and other things, you want to have these load balancing things, you can do it in the traffic. Now we can move forward and deploy our front ends, micro front ends, as we have these pillars, two pillars, this reverse proxy and the SSO server available in Kubernetes. So now we go. So what we have to do now? We have to deploy the console. First, we are deploying the discovery. Having it, we can deploy it later, but then as we will deploy the front end, it will look for the console server. It will give errors. So we come to that, and if we go pods or services, we will see we have deployed console. So we can deploy as many console as we want, one console leader and many console replicas. My machine, if we deploy all things, it becomes with this little container heavy. So I'm just deploying only one console leader, one Docker, but I have declared the service similar way and the deployment of the console leader and an ingress-controller if you want to expose it. But we don't want to see the expose now. Console is running. We can go to the log. There is a Docker running. We can see the log. Yes, it's running and it is already communicating all the services if you see. And things are running, the logs is there. So it's working. Now, if we have console, then we will deploy the Frontend 1. Frontend 1 doesn't have Kafka dependency. So we don't have to deploy Kafka now. Frontend 1 has dependency on key clock, on traffic, and on console. So we will deploy we can deploy now Frontend 1 because it will find all these things. So Frontend 1, as similar I told you, I just compose. I just run the compose and it has given me this Docker, where is that? Yes, this Docker file where I just modified a bit. This service used our labels and this deployment and this ingress route. And we have given this host name like this default host name and then path app1. And for app2, similar, everything is similar. The ports are different. The parameters coming similarly. I just have changed the path name for depending on the environment Kubernetes. I have given the path name, changed this path name. It was different for the Docker Swarm. And here comes the certificate part, right? The task store, we are saying the task store, it will look for the etc certs. If you remember, I forgot already. You can remember this zip. Where is the zip entry point? It will look for the certificate in etc certs. So we have to map it in etc certs. So we have done that. Where is that? Yes. So where is that? Okay, the volume. So we have mounted this config task store. So the file name, according to the file name, it will mount it here. Certs / whatever the file name is. The file name is trust store, capital store, file capital case. So it will, according same way, it will come amount here. So it will not give any error and it will find that, and it will be available on the local network on this path. And we have exposed this domain in this Cloud Shift environment. So it will find this domain and this path, it will be routed with our proxy server with this traffic engine. That's it. And that can be done because we have declared this ingress route. Currently, the ingress-controller is Traefik. So see, let's see, and another thing. Okay, I will show it later. Now see, our ports or services. Okay, we are running this Frontend 1 and Frontend 2, right? Frontend 1, there is a port. You see that there is a log. Okay, so it's running properly, and there is no problem. And the Joule, the API gateway connected with that, embedded with that. Basically, we are not deploying Joule separately. We are going embedded Joule proxy with each front end. So it will be embedded. So whenever the front end runs, the API gateway automatically runs with that. So there, this is that. And in deployment, we also have this content. And there is a feature in OpenShift, you can auto scale these things. So I'm not going on this auto scale or fine tuning of Kubernetes. You can see it yourself, but I'm just trying to show that our things are glued and working properly. So that's the thing. So our services are up and our pods are running front end. So can we see that? Is it working or not? How we can see that? We have to go to that path. What is the path? www.mmfb.kaligor.com is app1. So if we hit the app1, okay, it will not go, it will go to the authentication as OAuth2, and I have a user already. I will just log in and it is landing in Frontend 1. So if I do is Frontend 2, so it will not ask me to again log in. So this is SSO. We have integrated both two front ends with SSO, integrated that. We have deployed the SSO server, integrated that. And now in single login, we can log in into both sessions. I mean, both front ends. But this is the way front ends are working. So that's the thing. This is the exposure. Now, if we have done that, now we will go service 1 and service 2. But we know in fourth session, we have used this PubSub architecture. And for that, in service 1 and service 2, we have integrated that with Kafka. So before that, we go to service 1 and service 2, we will deploy the Kafka. And Kafka comes with Zookeeper as proxy, and we will have this Zookeeper as a service and Zookeeper deployment. We kept it all in one file basically to make it short. And also we are deploying Kafka with single instance basically. I'm not making it big or other nodes, just one broker. So this is Zookeeper deployment and this is Kafka deployment, same as Docker Swarm. I just used that compose file or the compose tool and converted that one, this one, and generated this one, and then just filtered some unnecessary things and labels. I have given these labels to find it. So that's it. And the other things automatically came here. I don't have to do anything. So that's the Kafka deployment. I have deployed it. And if you can see, the Kafka is also running. You see the log, it's also running, stabilized, and it's working. The broker, there is only one broker, it's working. So if we have Kafka running, then we can deploy the services. So we have two services, and as we know, we have developed the services with the same framework as Spring Boot. Just extra is removing the Angular part and adding the Kafka part, and rest of the thing was declaring some REST endpoints and nothing else. And this all rest of the thing is similar, declaring this Kubernetes file. Similarly, that compose tool has generated from this Docker compose file, from these services deployment. I've just derived it and changed some labels and some domain names. That's it. And that similar way Docker Swarm, and here that console host and the Kafka host we have passed from this environment so that it can change in the configuration as it wants, and the certificate similarly map the volumes. And here there is no root. You see, we don't need that, because why? We have not exposed it. We have exposed only app 1 and app 2 to the local networks environment, and not exposed only this domain. Services we have not exposed or not even exposed to Traefik. So Traefik will never know the service 1 and service 2. Service 1 and service 2 will only be known to the Joule proxy of the app 1. That is the only declaration we have done. If you remember in front end, so this is where we are securing things. Where is that? Here. Yes. So we are exposing service 1 only to Frontend 1 proxy, API gateway, Joule. So Traefik has no knowledge of this service. Okay, so that way, and similarly for service 2. And even service 2 is not known to service Frontend 1. To access service 2, we have used service 1. If you remember, in service 1, okay, sorry. In service 1, we have created a proxy, right? Yes, service 2 proxy. That is basically with the Fin client or HTTP client, it is calling, proxying a method of service 2. So there is no connection in between Frontend 1 and service 2. Service Frontend 1 only knows the service 1. And if service Frontend 1 wants some data of service 2, we are providing that through service 1 by proxying it. We are auto-wiring this proxy service and providing data by calling this proxy service from service 1. I think it's clear enough. We have done this earlier in our earlier sessions. I don't remember that, maybe 2 or 3. And this is the thing. So this is the layers of, encapsulation or authentication. You can think that the way we have secured things layer by layer, you can do it also as much as you want. So now we can use from frontend 1. Okay, let's see service 1 and service 2 is up or not. So we have this service 1 and service 2 running. Let's see service 1 pod. And I have not deployed Prometheus and Grafana in Kubernetes because it becomes load, and in my local machine it makes trouble. It becomes so slow. So I'm just showing only this part. So now Kafka, yeah, you can see service 1 is deployed. This is the service 1 and it is already connected with Kafka and it's working. So now if from frontend 1, I want to, I have already, yeah, I want to see service 1 REST call. Yes, hello service 1. Hello service 1 is a method, is this one. So I have invoked this endpoint and I got this output. Now if I invoke this one, that is basically using this proxy service. Okay, trying to use this service 2 now. From service 1, from frontend 1 to service 1 to service 2. Yes, that is giving this data. That is calling basically the service 2 info method and then aggregating it into an array and then exposing it. So this is the way proxying from one service to another service. I just made it too simple. You can do it with DTOs and entity callings and other things. I just try to show how it works, the gluing basically. So that's the thing. Now we are seeing that in Kubernetes platform, we can access frontend 1 to service 1 to service 2. Now we want to see using of Kafka. In last session, we have done that. We have created some consumer and publisher. So we have published in topic 1 basically, and we have consumed in this both service 1 and service 2. Service 1 is publishing and also consuming, but in service 2 we have only consumer, no publisher, right? So far I remember, yes, only consumer. Okay, so it's consuming all this channeling. If you see the service, I mean the session 4, you can see how we have done this coding. The difference, you will see the service 2 will give this output in console and it will give normal output. I mean only this data whatever we are sending. So we have to hit this endpoint. So we go that API.pub, we have already tested. So we see hello Kubernetes. For hello, it will add hello automatic. So we say Kubernetes. Oh, it's not saying adding not anything. It's only saying hello. Okay, maybe in console it showing that. We just go to our console and see. Okay. Yes, it said hello Kubernetes and makes it caps. So the piping we have done with Kafka, maybe in 4th session we have seen. In consumer, we have done some piping. We are getting the input stream, making it uppercase, then sending it, adding, aggregating a string with that, and then giving an output. The 3 tasks we are doing with this Kafka input we are getting. So there are 2 consumers. One consumer is service 1, and then we can see other consumer, that is service 2, right? We can go and see it is giving also service 2 received hello Kubernetes. So this is the output it's giving. It is done through Kafka. Maybe now if someone is new here, you will not understand. You have to see the session 4. We have done that part in session 4. Now just with the Docker Swarm, we are just deploying this part in Kubernetes, and we have seen without any code change, we are having the same Dockers. We have deployed in Kubernetes, same Dockers, images in Docker Swarm. Same Dockers are working in Kubernetes. Okay, or maybe I have not shown that. Yes, here in Kubernetes. So we have put that in this Docker IO, that's pushed our local images to Docker Hub. So this my local cluster can get this from that repository. and read me, yes. So you just done this, tag this, and push these things to whatever repository you want. You can push it, and then from that it will just pull the Docker. So that's the thing I'm trying to say. The single development you can use and deploy it in multiple environments, multi-clouds, work. It will work seamlessly. That was our purpose, to show basically and fulfill this architectural thing, and having this 2 layers of load balancing, basically one load balancer for the front ends and one API gateway for the microservices, and with this discovery console. And then this whole thing you can have individually, all depending on the problem domain, you can have different teams and services with services and front ends. And you can have a seamless thing. So front-end user will never, they doesn't need to know basically the end user. You are doing with Kubernetes or you are doing with microservices. They do not bother basically. So they need a seamless UI. So whatever way you do, you have to give them a single sign-on and a seamless UI. So whatever path or changing, you are maybe serving 2 or 3 UIs, I mean micro frontends, but to them it will appear like it's the same thing with that UX things you will do. Otherwise it will sound odd. So that's it so far for today. And okay, oh, and for deployment I have done also like this. Okay, I just, if you want to do in one deployment, so you can like do like this. So the namespace thing, like I am doing it currently, the files are written with MMFB namespace, but maybe I want to deploy in MMFB dev1 or test. So there can be multiple namespace in Kubernetes environment, one for dev, one for test, one for production. So it can be different namespaces. So you may need to do some templating on these YAML files. So there are lots of tools for that, but you can use simple. I have used simple set for the shell command, you know. So just changed this. I show you that. There's a namespace, right? For everything namespace. So if I want to deploy in different namespace, that is not this namespace. So before deploying, we just change this thing and do this simple replace command of shell, and all the files basically I have sequentially. It will automatically with single. It will create the secret. It will create the config map, and it will create the all the deployments and services. The whole thing will be deployed in single command. All the things I have shown you individually each one, but it can be easily deployed as shell file. There are other tools you can deploy these same things in many other ways. That is something DevOps administration part. I don't want to go on there. That's not my part basically. So the thing we want to show here, that without having that complexities in mind, you can easily test your application in Kubernetes, in Docker Swarm, in any cloud, and you don't have to be locked in with any vendor, not even Kubernetes. You can deploy that with simple Docker Swarm and then deploy it to Kubernetes. It's not that you want to create a microservice architecture with Kubernetes. For that, you don't have to start development with Kubernetes. You can easily start development with simple Dockers, but in a strategic way. So later on, you can deploy it in Kubernetes, or even you can test it with Docker Swarm in your local machine, or even if you feel in production, Docker Swarm is also production ready. You can also deploy it in Docker Swarm, even avoid Kubernetes. So in a single, you don't have to change anything from that. So this is the flexibility, this is the thing, and this is the freedom I think you should look for. So our product should not be locked in or blinded or married, tightly coupled with any vendor. So that's the thing basically of cloud agnostic way, thinking the philosophy of cloud agnostic way in the with the open source tools. I think that's the part. I'm just stopping my share now. If you have any questions or anything.
ভিউয়ার্স, আপনাদেরকে অনুরোধ করব, আপনাদের কোনো কোশ্চেন থাকলে, ইফ ইউ হ্যাভ এনি কোশ্চেন, জাস্ট চ্যাট বক্সে জানান আমাদেরকে। ইট ওয়াজ অ্যান এক্সেলেন্ট সেশন। এটা আমাদের বুট ক্যাম্পের শেষ সেশন, এবং এখানে আমরা অনেক কিছু রিক্যাপ করছি আর্কিটেকচার নিয়ে। আমার মনে হয় ক্লাউড অ্যাগনস্টিকের যে ফিলোসফিটা আপনারা সবাই বুঝতে পারছেন, এবং কেন ক্লাউড অ্যাগনস্টিকটা হেল্পফুল। কিছু অসুবিধা আছে, কিন্তু ম্যাক্সিমাম টাইমে কিভাবে হেল্পফুল, আপনি কোনো ভেন্ডরের সাথে বাইন্ডিং না, এই সব কিছু মান্না মাহমুদ খুব সুন্দরভাবে এক্সপ্লেন করছে। তারপর আপনাদের কোনো কনফিউশন থাকলে, কোনো কোয়েরি থাকলে অবশ্যই আমাদেরকে জানান কোশ্চেন বক্সে।
So I have shared I'm sharing the slide from these Google Docs. Make it anyone can access. Made it. So you can click and you can test. You can see that this is the only basic slide basically. Rest of the thing we have done coding, right? We have shown different coding. So slides are, we have not gone through slides. There is only one slide basically. So we can use it. Someone has asked for that. So this is the thing.
Excellent.
Anyone with any question?
I'm just waiting for it. Someone thanked you. I think everyone is just grasping it or try to make understand all of the things. Maybe there might come up some questions later. I hope everyone is fine with that.
Maybe you can communicate with me if you have questions. There are video links, right, in YouTube. Cloud Pro. YouTube. You have the link, and if you want to, should I share my email here?
You can share your social. If you feel email is quite personal, you can share your social media links like Twitter, LinkedIn.
Okay, no problem. I don't use Twitter that much. I'm not from America. In Bangladesh, this product is not much worthy to people, but I use LinkedIn a lot. I am available in LinkedIn. So, what is the chat box here? And this is, oh sorry, no. This is me. You can. This is me. And Facebook is basically something. It's not for. I mean, something.
Yeah. It's quite personal. If you have public pages, you can share. But apart from that, don't share the personal.
I normally practice everything with open source things. So I have expertise. I am connected currently with two organizations. One is Karigor. It's not a company. It's a community basically, Karigor. And Karigor is basically doing all these open source practices with some renowned open source tools. And I'm also connected with a company called ADN Diginet as their consultant, chief architect. And I'm providing solutions in this microservice in Python and in Java. We have seen in Java, but I also do the same thing with Python too. So that's the thing I wanted to say you earlier. This is the idea or concept. This is not the language. I mean, it's not Java or Python, something like that. This concept can be adapted in any language, in Python, in PHP, in Java. So you just have to have your connectors and clients according to your platforms and things, but it will give you more loosely coupled environment, and you can grow or scale it as much as you want, and depending on the IO or the load of the specific service and the front ends, and the development will become easy. The philosophy I have said in the first thing, that if you want to develop a microservice, don't start from the backend. Don't start developing microservices. I have seen the team. I have seen many teams. They just got the requirement and start planning the microservices, 20, 25, even 30 microservices, and then they consume that in the front end. But I think it should not be the approach. The approach should be from the requirements. You will determine first the UI, then the UI and the UX. It will give you the output, input and output things, data models, the DTOs, the entities. then you will define the services. So most of the cases, I think I have seen people go a bit backward. Created microservices, then goes for the front ends. So I think you guys should be aware on this. Don't go that way. If you want to do something large, don't mess it up. Go from top to bottom. Check out the requirements. Design your front ends. It will be easy for you to understand how many microservices or what should be called microservices.
Yeah. I'll request Ashfaq to join this conversation if he has any experiences. You can also share, Ashfaq.
Yeah, of course. Thank you.
হ্যাঁ ভাই, সো আলটিমেটলি তো আমরা শেষ করলাম, মানে আমি ওইটাই আপনার লাস্ট কথা ধরেই আমি একটা কমেন্টও করছি যে এক্স্যাক্টলি এইটাই আমরা করে আসতেছি, যে উই সি দ্য রিকোয়ারমেন্টস অর দ্য ইউজার what we call user story, we first define those backend services. So ওইখানে দেখা যায় কি ওইটা করতে যে এতটা মেসি হয়ে যায়, দেখা যায় আমার ফ্রন্ট এন্ড টিমের সাথে পরবর্তীতে আবার ফ্রন্ট এন্ড থেকে যখন রিকোয়ারমেন্ট আসে we have to redesign the architecture. So আমার রিসেন্টলি একটা প্রজেক্টে আমাদের basically at our company we share SMS services. So to speed up the process we have Python service in the backend. So for report module we had to implement some kind of extension of that. So যেটা অলরেডি আছে সেটা থেকে আরেকটা আমাদের বানাতে হয়েছে just to make sure যে the process is faster and all. So আমরা সেই কাজটা করছি, আমার যে সিটিও আছেন তার সাথে বসে আমিও ওখানে আপনার ছোট টিমটার একটা লিড হিসেবে আছি ছোট অবস্থায়, বাট ওই আমরাও ডিসিশন নিয়ে ফেলছি যে এখনো দেখা যায় যে আমি মাঝে মধ্যে ফ্রিল্যান্স যে গিগস গুলা করি ওখানেও আগে ডাটাবেস তৈরি করো, সার্ভিসেস তৈরি করো, তারপর দেখবো না ফ্রন্ট এন্ডে একটা টেমপ্লেট বসাইলে হবে, সমস্যা নেই। বাট what we learned from you is that যে we have to focus on the UI UX first, design it, then see the requirements and build the microservice only on that. So that is a much better approach I think.
Yeah, organized, much organized.
Exactly.
And microservice is not just REST APIs, right?
Right. That's another concept that has been cleared through these sessions.
Absolutely. That's very good. Thank you.
Yeah, thank you.
Satisfying that we are having some understanding that is common.
Yeah.
Okay, that's good.
থ্যাংকস মান্না ভাই। আমরা অনুষ্ঠানের শেষ প্রান্তে চলে এসেছি। এটা একটা এক্সেলেন্ট সেশন ছিল। ভিউয়ারদের অনুরোধ করব বুটক্যাম্প সম্পর্কে তাদের মতামত biocloud@gmail.com এ ইমেল করে জানাতে পারেন। টেকনোলজি রিলেটেড গুরুত্বপূর্ণ ভিডিও আমরা আমাদের ইউটিউব চ্যানেলে নিয়মিত আপলোড করি। এছাড়া আমাদের পরবর্তী ওয়েবিনারের ভিডিওগুলো দেখতে চাইলে আমাদের ইউটিউব চ্যানেলে সাবস্ক্রাইব করুন। এছাড়া সোশ্যাল মিডিয়াতে আমাদের কমিউনিটিতে যোগদান করে আপনাদের মতামত জানাতে পারেন। আমি আমাদের সোশ্যাল মিডিয়ার লিংক এবং ইমেল অ্যাড্রেস পুনরায় আমাদের চ্যাট বক্সে দিয়ে দিচ্ছি, আপনারা দেরি না করে ক্লিক করে সাবস্ক্রাইব করে ফেলুন।
থ্যাংক ইউ অল।
ধন্যবাদ মান্না ভাই, ধন্যবাদ সবাইকে তাদের সময়ের জন্য। আমি আমার অনুষ্ঠান এখানেই শেষ করছি।
Thank you Manna bhai. Assalamu alaikum.
You're welcome. Thank you too. Bye.
Bye.